I would love to start class off today with a little celebration, but I only think I'd be the only one celebrating. Welcome back. Welcome back, everybody. It's been since Unit 7, and we're on Unit 10 right now, but welcome back. There they are. Statements, reasons. Silence. That's what I expected. And I love it. Love it. That makes me happy. Your misery is my enjoyment. We're not ready to start yet. Can we review? How am I going to do this? Forget about the diagram and the givens. Quick review. Heck, we got a Regents in less than 3 months. Ways I'm going to be able to do this. Let's go. What do you got? Angle, angle, side. Side, side, side. Side, angle, side. Angles in between. Ooh, nice. HL, the forgotten one. But only if the triangle's what type? Right triangle. And then what am I missing? Angle, side, angle. There are your 5 ways we could do this. All right, only 5 ways. And we're not making up a 6th way because it's March. Those are the only 5. All right, ready to get to it. Let's use our theorems from yesterday. I got arc AC and arc CB are congruent given to me. So we can just mark those with hash marks. All right, now it's on you. If those arcs are congruent, anybody want to tell me any facts that are are true on this diagram? Sides or angles, doesn't matter. 7, want to start us off somewhere? Okay, that's a true fact. Let's write it down. AC congruent to CB. We wrote this reason down yesterday in your notes. What was given true? What was already given? Congruent arcs, right? The arcs were given. So I'm going to start with congruent arcs. Imply. What did Emma just give us? Congruent chords. There it is. Thank you. 1 pair of sides down. There's 1 pair of sides. Need more, though. You guys know I don't have just an S rule. All right. What else is true? Oh, 4. Anything else you want to throw at me? All right. That is true. Angle AOC is congruent to angle COB. Boom, boom. All right, what are we going to write here now? Again, what were you given? Congruent arcs imply. And Molly, you gave this to me, right? And what did Molly give us? Congruent. Be careful. Don't just say angles. That's not true. You got to be specific here. Congruent arcs imply congruent central angles. Good. Zach? Might as well just go with the OC equal to itself, right? Everyone agrees that shares OC. Yeah. You guys are making this a lot longer than it needs to be, but I'm going to keep writing. Are those triangles congruent though right now? Nah, they're not. Is this side angle side? No, that angle's not in between. So unfortunately, even though we have 3 pairs of congruent parts, the triangles are not congruent by any of these methods. All right, this angle is not in between these sides, and I don't have any other method to use here. So keep going. There's got to be something else true, Carter. Yep, we went over this yesterday. AO is congruent to OB. What are those 2? Those are what in the diagram? 10. What are AO and OB? Those are radii, right? And what do we know? In a circle, they're all congruent. It's fine. It happens to everybody. In a circle, all radii are congruent. Did we talk about how to spell that yesterday? Double I. Great Wordle word, by the way. That ever came up. Getting the double I's there. Do I have any players in here? This past weekend. Whew. Rough. Throwing the X in there on Saturday, I think. And then what was Sunday? Sunday was a tough one, too. So Sunday was the no vowel one, right? Nobody else could help me here.
It was
what was it?
Nymph.
Nymph. Yep, that's right. That was a tough one. All right. Now I have enough information. And hey, does everybody see you actually have two ways you could prove the triangle's congruent, don't you? What's one way I could prove them congruent now based on all this info we have? 19, I could go side, side, side. Or based on all the info we have too, I could go where instead of side, side, side? 3? You pick. Side, angle, side, 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 side. They're both there. Triangle BOC. Congruent to triangle AOC. Side, side, side. And I'll just put slash side, angle, side. You can pick. Epoxy. That's what it was Saturday. Only reason I do it, by the way, no interest in the English language or English in general or vocabulary in general, just so I can do it quicker than Mrs. Carlino every day. Only reason I do it. And most of the time it doesn't happen, I'll be honest. She kicks my butt. So I just accuse her of cheating and looking it up on Google. You can look at my Google history. I'm good, thanks. I'm good. Questions?
What's your Google history show?
Mine?
Yeah.
TimesUnion.com maybe. ESPN. Probably some theories on some of the shows I'm watching.
Did some of them include Chris Rock?
No, they don't.
Man.
No, I don't need to Google that. Other questions? Just integrating some pop culture into our class. Yep. All right, next up, next proof. Now we're not asking you to prove the triangle's congruent, but we're asking you to prove the angles. So back in the day when we did this, you could not prove a pair of angles congruent unless the what were congruent first. Yeah, remember that? We proved the triangles congruent so we could say the angles. Anybody remember that last step, what it was called? Let it roll off your tongue if you don't. CPCTC. Yeah, CPCTC. So help me get the triangles congruent first so we can do CPCTC. Help me get the triangles congruent so we can do CPCTC. All right, what's given to us? OC is perpendicular to EF. So I know right angles are formed. Anything currently from the circle unit or anything we've used in the past that will help us get sides or angles here. Help me out. Anything from the circle unit or anything from the past that'll get me sides or angles in these two triangles. Talk to me here. 5. Yep, get that out of the way here. CW, congruent to itself, reflexive. That gives me a side. Reflexive. Good. Anything else in this diagram you know are congruent? 2. Okay, I'm glad you said that. All right. It will be in a second, Molly. It will be in a second, but it's not in step 3. Everyone see what theorem she's using. Yesterday I showed you radius, diameter to a chord does what to the chord? Bisects it. So that's where Molly's getting that these two pieces are equal. But there's the problem though. That theorem doesn't say the two pieces are equal, does it? It just says the chord's getting what? Bisected. So that's what I'm going to write in step 3, is that OC bisects EF. All right, OC bisects EF. It doesn't say the two pieces are equal. We'll get to that in a second. Everyone all right on how this theorem's used? The theorem needs to be used to say a chord is getting bisected. And the reason, radius, diameter, whatever we want to put, we talked about that yesterday. Perpendicular to a chord bisects the chord. All right, again, I'm only using this theorem to say a chord is getting bisected, not the pieces are equal. Now you tell me why. Why can I now write what Molly just said? EW congruent to WF. Former reason. Former one, nothing new. Why are the two congruent now, Zach?
Definition of a bisect.
Definition of bisects, right? Remember that back in the day? So that's how I get the two pieces equal in these circle groups. Definition of bisects. All right, so I got two sides. I got my reflexive and the two pieces of the chord. There's got to be something else here I can write. I need one more pair of something. And don't overthink it. Don't overthink this. It's right there for you. 10.
CWF is congruent to angle CWF is congruent to CWE.
In a minute. Remember,
Perpendicular first.
two-step process, right? Two-step process to say the right angles are congruent. You need to tell me first they are right angles. Angle EWC and CWF are right angles. Perpendicular lines form right angles. Remember this? Two-step process. Now you can say they're congruent. And I think most of you guys could be on your way now. EWC congruent to CWF. All right angles congruent. And now we got what method to say the triangles are congruent? 3. What method you have? Yep. Anything with the proofs? I feel like I wanted to get those out of the way first using our new theorems, and now we'll do some algebra problems using our new theorems. So if you don't have them out already, probably calculator would be good use here. All right, here we go. I don't think you guys will find these too bad. Go ahead, read through. We got radius OC is 5, chord AB is 8, and it's perpendicular. What's OP? What's the length of OP? All right, anything you know is happening here? Based on some of our facts from yesterday, what's anything you see happening in this diagram? Any of the facts being used here? 11, anything you see here? We got an 11?
Oh, yeah.
Oh, hi, Zach. Anything you see is true?
It's being bisected.
Yeah.
AB is being bisected.
AB is being bisected. And don't I know the length of AB is 8? So what are we all putting on AP and PB? 4, right? 4 and 4? Everyone all right? The radius is bisecting the chord. OP. How are we going to figure out OP here? Radius is 5. What if I happen to draw in another radius? How long would it be? Oh, would it be? Is there another place I could draw a radius in that might help me find what OP is here? Could I draw in another radius somewhere? Because I already know the length. That might help me find the length of OP. Suggestion, Carter.
You could draw it to like OP.
Or OA, right? I could draw it to O. Watch, ready? Connect O to B. Everyone agrees that's a radius. How long is that radius we just drew in? 5. Why is that going to help us now to find OP? Pythagorean theorem. Good. Good. So all I needed to do is draw in another radius that would help form a right triangle so I can do Pythag. And you're not off the hook yet. Where do the 4 and the 5 go? 4? Where's the 4 and the 5 go? Perfect. 4 squared plus b squared equals 5 squared. Let's see. 11. How long's OP? 11.
Oh yeah, it's 3.
3. All good. All right. And one doesn't make you great. Look at those dreaded directions at the end. Simplest radical form.
Yeah.
All right, so let's talk. I got OA is 6. OE is 2. Got it. How long is CE? Ooh. How long is CE?
Okay.
Suggestions? Via?
Draw another radius.
Anywhere in particular?
From O to C.
Okay, sure. And how long is this radius you're having me draw in?
6.
6, good, because OA is 6, and that's a radius too.
Yeah.
So that's 6.
Real.
Anybody suggesting anything for X? How can I find X now? I can use Pythag. Even though it's not on the diagram, it does say it's perpendicular to chord CD, right? So a little right angle symbol there. A squared plus B squared equals C squared. Let's see, what do I have here? 2 squared plus B squared equals 6 squared. So B squared ends up being 32 when I move the 4 over. Ooh. I know it's been a while. Simplest radical form. What's 32 break down into? Ooh, nice. I'm glad. Because I know you automatically you try 4 and 4 works. It's not the biggest. All right, because look, remember, I know you don't remember my trick, but you do 4 and 8. Look at that second number. Is there still a perfect square that goes into 8? Yes, which means that's not the biggest. 4 is not the biggest. It's actually going to be what? 16. Good. And 2. So we end up with 4 square root of 2, which is fine. And that's the answer. That's what I'm looking for. I got a not challenging one, but another follow-up question. What if I wanted to find the length of CD now? Chord CD. How could I use my answer of 4 radical 2 to find CD now? What's happening to CD? It's getting bisected, right? So if CE was 4 radical 2, what's ED? Also 4 radical 2. Ooh, how would you add those up? What would it be if you added them up? Oh, thank you. Thank you. You're learning something. 8 radical 2. Yep. All right. All good? Questions? What do I have? 3 homework problems tonight? Ooh, really laying it on thick. All right, go ahead. Let's get going. I don't need to assign any more. Definitely could get out of here without nothing.